The global aviation stage has been dominated for half a century by a duopoly, the elegant European ballet of Airbus and the powerful American march of Boeing. Their duel is reminiscent of the eternal rivalry between Coca-Cola and Pepsi, where the buyer essentially has a choice without a choice. Any airline wanting to buy a modern narrow-body airliner is doomed to spin the roulette wheel between the A320neo and the 737 MAX. Until now. In 2008, while the West was plunging into the vortex of the financial crisis, a different drama was unfolding behind closed doors in Shanghai. China, for decades, a mere patient spectator in this show, quietly but decisively placed its own card on the table. Its name? COMAC C919. This is not just an airplane. It is a geopolitical manifesto made of titanium and composites. A statement of intent wrapped in aluminum skin. The game had begun. The idea wasn't born in a vacuum. The Chinese aviation industry had been building strength for years, assembling the Airbus A320 under license and studying the Boeing 737 under a microscope. But being an assembly workshop is a fate worthy of the last century. A country that intends to rule the world of economies cannot forever depend on the wings of others. Thus, the Large Passenger Aircraft Project was born, a symbol of national pride, technological maturity, and strategic independence. The goal was formulated without mincing words, to create an airliner capable of taking a solid bite out of the juiciest segment of the market, medium-haul travel, right in the teeth of the A320neo and the 737 MAX. COMAC's plans sounded not just ambitious, but Napoleonic, to capture 1/5 of the global market by 2035. This isn't a business plan. It's a declaration of war, signed by the Chinese leadership. The path from blueprints to the runway took 15 years, a span during which Boeing manages to change 3 generations of managers and Airbus launches 2 new modifications. But for China, this was a forced march, development from scratch, thousands of tests, countless prototypes. The first flight in 2017 was a moment of national triumph, comparable perhaps to the launch of the first Shenzhou spacecraft. And in May 2023, when the first serial production C919 of China Eastern Airlines completed its commercial flight from Shanghai to Beijing, the world finally realized this is not a concept, this is reality. And this reality is already backed by numbers. In COMAC's order portfolio are over 1,100 aircraft, a figure to make any analyst's head spin. Of course, for now, almost all the orders are from Chinese airlines and leasers, which looks more like a Great Wall of China strategy. First, strengthen the domestic market by building it around your own product. It's a genius move to create guaranteed demand, ensuring the aircraft's initial viability while it gains strength for the battle on the global arena. The C919 is an aircraft of paradox. It is proclaimed as the first fully domestic Chinese narrow-body airliner, yet its heart, the LEAP-1C engine, is a product of the international CFM consortium, a joint venture of American GE and French Safran. The control systems, avionics, they are also largely Western. This is not a weakness, it's a sober calculation. China did not bother to reinvent what was already invented and perfected. Instead, it focused on the main thing: airframe design, systems integration, and most critically, control over the final product and its entire creation chain. It didn't start with a blueprint. It started with the ticking of a clock. Somewhere in the 2000s, Chinese air traffic controllers looking at their radar screens saw nearly the same picture every time, and endless silver silhouettes, Boeings and Airbuses. Every takeoff, every landing could be counted as a transfer from the state treasury to the coffers of Western corporations. The economy was growing at a double-digit pace. The country was becoming the world's assembly workshop, but the sky belonged to others, a paradox they could not tolerate forever. The answer wasn't born in a hangar, but in the offices of Beijing. 2008. While the world was licking its wounds from the financial crisis, China made a cold, calculated move. From the merger of state aviation assets, COMAC, the Commercial Aircraft Corporation of China, was born. The mission was formulated without lyricism: break the duopoly. Create not just an airplane, but its own standard. And the point of application was no accident: the narrow-body segment, the workhorses of global aviation. Those very Airbus A320s and Boeing 737s that shuttle like taxis between Shanghai and Beijing, Guangzhou and Chengdu. Thus, the C919 project was born. The number 9, a symbol of longevity in Chinese culture. The 19, indicating 190 seats. This wasn't just an engineering challenge. It was a shot into the future, aimed at the next 50 years. The initial plan sounded like science fiction. Produce around 2,300 aircraft. That number wasn't pulled from thin air. It was a direct statement. We intend to replace the lion's share of the imported fleet in our home market and take a solid bite out of the global pie, an appetite worthy of a dragon. But dreams are dreams, and aviation is a religion where God is in the details, in the certificates. In 2010, COMAC applied for a type certificate from the Civil Aviation Administration of China, CAAC. This was a declaration of serious intent. We are playing by the rules. Yes, our rules, but rules nonetheless. And then came the move that made the whole world raise an eyebrow. 2011. COMAC signs a Memorandum of Understanding with Ryanair. Yes, that Irish low-cost giant, the king of budget travel, whose business is built on ruthless cost-cutting and haggling over plane prices. This wasn't just a PR stunt. It was a masterclass in aviation geopolitics. The Chinese had invited the most demanding and frugal dance partner to the floor, sending Boeing and Airbus a transparent signal. Folks, your captive customer now has an alternative, and he's not afraid to bargain. The project's budget? Over $20 billion, a sum comparable to the budgets of small countries. That money was an investment not just in titanium alloys and composites. It was the price of admission to an exclusive club. A club that, until then, had only 2 members, Seattle and Toulouse. China bought itself a ticket, an expensive, long-term ticket, but a ticket nonetheless.
So that's how the C919 was born. Not from a dream of flight, but from cold calculation, a giant check, and iron political will. The foundation was laid. Now came the hardest part, turning ambition into metal, wiring, and flight certificates. The story was only beginning, but its first chapter already sounded like the promise of a great race. A race where the rules were being written on the fly. The story of the COMAC C919's development and design reads less like a triumphant manifesto and more like a masterclass in pragmatic ambition. It's the tale of a newcomer not just building a plane, but navigating a minefield of global expectations, technological dependencies, and cold, hard commercial calculus. The preliminary design freeze in 2011 wasn't a starting gun. It was the moment the real balancing act began. From the outset, the challenge was aerodynamic legitimacy. Instead of relying solely on traditional wind tunnels, Chinese engineers enlisted a digital oracle, the Tihan-2 supercomputer. This wasn't just a tool, it was a strategy. Millions of computational fluid dynamics simulations sculpted the wing and fuselage in a virtual realm, optimizing for the holy trinity of commercial aviation: lower drag, less fuel burn, more range. The resulting wing is a silent protagonist, its form born from countless digital iterations to cheat the wind with maximum efficiency. Yet for all its digital ambition, the project soon faced a very material reality check. Early blueprints championed advanced carbon fiber composites for the wings, a bold statement of technological parity. But the allure of state-of-the-art collided with the disciplines of cost and manufacturing complexity. In a decisive pivot, COMAC's engineers performed an act of profound pragmatism. They retreated to the known world of aluminum alloys for the primary wing structure. This wasn't a failure of innovation, it was a declaration of commercial intent. The plane had to be buildable and profitable. Composites were strategically reserved, making up about 12% of the airframe in non-critical panels and tail sections. The heart of the machine presented another high-stakes compromise. Selecting the CFM International LEAP 1C engine was a stroke of geopolitical and market genius. By choosing the very power plant that propels its chief rival, the Airbus A320neo, COMAC executed a brilliant trust transfer. They sidestepped the immense hurdle of certifying a novel, unproven engine. To airlines, the message was subliminal yet powerful. You know this technology. It's efficient, reliable, and your mechanics understand it. It was a shortcut to credibility, purchased from the West.
This global sourcing became the project's defining signature and its potential Achilles heel. The avionics suite from Honeywell, the flight controls from Liebherr, the landing gear from Liebherr Aerospace. The C919 emerged as a mosaic of international expertise. This global supply chain was a double-edged sword. It guaranteed world-class subsystems and eased certification concerns with foreign regulators, but it also wove a web of strategic vulnerability. The plane became, in essence, a globally sourced product assembled under a Chinese flag, its fate subtly tied to international trade flows. Where COMAC sought a clear competitive edge was inside the cabin. The fuselage was consciously designed to be slightly wider than its main rivals. In the standard 3+3 single-aisle configuration, those extra centimeters translate into a tangible passenger promise. Less shoulder clash, a perception of space. It's a direct, physical appeal to the flying public's most common grievance. Binding all these elements together is a nervous system worthy of the 21st century. The C919 embraced a full digital, network-centric avionics architecture based on AFDX, or Avionics Full Duplex Switched Ethernet. This move from traditional federated systems to an integrated network is a foundational upgrade. It simplifies wiring, dramatically eases maintenance diagnostics, and, crucially, future-proofs the platform for software-based enhancements. It's the kind of infrastructure play that delivers value for decades. The hangar in Shanghai, 2011. It doesn't smell of dreams here, but of carbon fiber resin, metal, and cold calculation. This is where the bones and flesh of the idea are born. On the assembly lines, slowly, centimeter by centimeter, what was meant to be not just an aircraft, but a symbol, begins to take shape. The future skeleton of the C919, the fuselage frame, the wing ribs. The work proceeds to the accompaniment of low but distinct doubts from around the world. Can they really do it? That question hangs in the air, thicker than the industrial haze over the Yangtze.
And then, after 4 years of titanic assembly, the Shanghai hangar opens, 2015. Into the light, or rather, under the spotlights and the lenses of thousands of cameras, the firstborn rolls out. Prototype number 001. It is impeccably white. It is silent. It is a giant blank page on which a story has yet to be written. That moment is a pure PR triumph. The world gasps. It's real. But the engineers at COMAC know the hardest part begins now. An aircraft is not a statue. It must fly. What follows are years of nervous, methodical, sometimes tedious, and sometimes deadly dangerous dialogue with physics. Ground tests, shakes, vibrations, the screams of overstressed metal. System by system proves its right to exist. And then the runway.
May 5, 2017. The date is no accident. In Chinese transcription, 5.05 echoes the word for flight, a good omen, almost a superstition. 2 pilots in the cockpit, hundreds of engineers on the ground with hearts frozen in anticipation. The CFM International LEAP-1C engines spool up to takeoff power, and finally it lifts off. First flight, 80 minutes of pure magic and cold analysis. Gear up, gear down. Not a heroic ocean crossing, but a modest, infinitely important shuttle over its home. The core message to the world: it flies, it is obedient, it does not fall. Basic airworthiness confirmed. On that day, China ceased to be a country that only assembled others' aircraft. It became a country that could make its own fly. But one successful takeoff is merely the opening paragraph. The main chapter begins harsh, long, and with no right to pretty pictures. 5 more prototypes take to the sky. Each is a flying laboratory, each with its mission. One is tortured in extreme regimes, another tests the autopilot, a third freezes in the natural refrigerator of the country's north. Total flight time surpasses 4,200 hours. They throw it through turbulence, check the behavior of the enormous carbon fiber composite ailerons, almost revolutionary for China. Light, strong, but finicky in production and tuning. And here the story grows real problems, not ceremonial ones. The schedule, initially as optimistic as all schedules in aviation, begins to crack. Component deliveries falter. Somewhere in the depths of the structure, teething troubles emerge, requiring not cosmetics, but surgery. Politics bursts into the workshop with shouts. The United States levels accusations of industrial espionage. Suddenly, access to certain technologies and even common parts becomes a matter not of logistics, but of diplomacy. Each delay isn't just a date pushed back. It's millions of dollars, the suspicious glances of partner airlines, the gleeful headlines of competitors.
But this was precisely the point of all this giant flying quality control. The tests aren't for a check mark. They are to find the weak link before it finds you at 10 kilometers up with 100 souls on board. Every malfunction identified and fixed, every delay paid for with the nerve cells of managers is an investment not in a report, but in future safety. The C919 didn't just undergo tests, it was forged through them, losing the sheen of novelty but gaining the resilience of a production machine. And when the last prototype made its final approach, the test program closed not with a feeling of finally, but with a cold, documented conclusion. The aircraft is ready. Ready to leave laboratory conditions and face the routine of daily flights, the whims of the weather, the stringent demands of airlines. The first flight was a celebration. Those 6 years of testing that followed were the heavy, invisible work that turns a symbol into transportation. It looks like just another narrow body in the crowd, the same classic tube with wings shape, the familiar silhouette at the gate. But that's the C919's greatest illusion. Beneath its external mimicry of the A320 and 737 lies an engineering strategy best described by old pirate wisdom. Keep your friends close and your enemies closer. Chinese designers took the global standard as a baseline and then meticulously went over its pain points to offer not a copy, but an alternative. Let's look under the skin. The skeleton, its airframe, is still the kingdom of aluminum, roughly 88% of its mass, a material proven over decades when every aircraft maker in the world knows how to work with. But where it provides a real advantage, in the wingtips, tail components, fuselage skin, composites now reign. That 12% isn't for a press release checkbox. It's what shaves tens of kilograms off the weight of each part. And in aviation, every kilogram saved translates to tons of jet fuel over the aircraft's lifespan. A wingspan of 35.8 meters isn't just a pretty arc. It's an aerodynamic tool designed from scratch to generate more lift with less drag. An aircraft 38.9 meters long is a careful balance between capacity and ground maneuverability. It must fit the same gait as its rivals, but feel more spacious inside. Now we come to the machine's heart. Today, it beats with a Franco-American accent. The CFM LEAP 1C engine, the same family lineage that powers the Airbus LEAP 1A and the Boeing LEAP 1B. But this C is the special Chinese variant. It has a slightly larger fan diameter, meaning slightly better fuel efficiency at cruise. It's like taking the world's best engine and asking engineers to fine-tune it specifically for your aerodynamics. Strategically, however, its own replacement is maturing under the cowling, the CJ1000A. Still in testing, its shadow already looms in every conversation about the C919. It's the future ironclad argument for full technological independence. This is where the C919 transforms from an apprentice into a serious player, in its nervous system. The flight deck and all avionics are no longer a Babylonian confusion of dials and gauges. It's an integrated digital ecosystem based on Ethernet. Imagine all the aircraft systems communicating not in whispers over old wires, but shouting data across a wide digital highway. This means pilots get information orders of magnitude faster and more intuitively. It means a mechanic plugging in a laptop sees not just a fault list, but a detailed medical history with live parameters. Reliability increases not because parts are tougher, but because the system warns of any potential issue well in advance. This is the technological leap that lets the newcomer sit at the table with the titans. In the passenger cabin, it's austere but honest economics. The 3+3 layout isn't about luxury, it's about efficiency. The idea of packing the most passengers into a narrow fuselage this way wasn't invented in China, but here it's been executed to a level on par with the competition. The passenger won't see a revolution, they'll feel an absence of discomfort. Seat width, ceiling height, overhead bin size, all are calibrated to market benchmarks. Why reinvent the wheel if you can make it roll a bit smoother? For now, the C919 isn't reinventing the cabin. It's mastering its manufacture at industrial scale and to the highest quality, a challenge for China as ambitious as the design itself. Now the numbers that turn this bundle of tech into a commercial argument. Maximum takeoff weight, 78.9 tons. That's its class ticket, its passport into the same weight category as the A320neo and 737 MAX. A range of 5,555 kilometers for the ER version isn't intercontinental, but it confidently covers China's vast domestic market and all neighboring capitals. Routes like Shanghai, Singapore, Beijing, Bangkok, Guangzhou, Delhi are its natural habitat. A cruise speed of Mach 0.785 is also a statement. We're not lagging, we fly just as fast as they do. No compromises here. The sum of the C919's design is not a breakthrough. It's the flawless assembly of a puzzle using the best available solutions of the moment. Global engines, progressive avionics, a hybrid material airframe. Its strength isn't in one phenomenal part, but in how all these parts are brought together into a single project controlled from one center, Shanghai. It's an integrator aircraft, a manifesto aircraft. It tells the world, we've learned all your rules, now let's play. And its ultimate trump card isn't about being better. Its card is about being no worse, yet being your own. And in a market with two players, the arrival of a third, even just an equal one, is itself a tectonic shift. The vast COMAC assembly line in Shanghai is the cathedral where a dream is forged from metal into machine. But behind the glossy photos of finished aircraft lies a different narrative, one of a serial production process that collided head-on with the gritty realities of global politics. The initial plan was audacious, to hit a rate of 50 aircraft per year by 2025, a number meant to signal to the world in no uncertain terms, we are here and we are here to stay. But global supply chains, those delicate intertwined arteries of modern industry, snarled. Sanctions and restrictions, biting hardest in the realm of high-tech imports, became the grit in the gears. The plan had to be recalibrated in real time. The current target is a steady drumbeat of 25 to 30 planes annually. Not a sprint, but a deliberate, scalable march. Assembling the C919 is an exercise in completing a global puzzle, with China reserving the final, decisive fit. The wings, the fuselage, that happens here. But the heart and nervous system, the Franco-American CEFM LEAP 1C engines, the avionics, the flight control systems, flow in from abroad. In 2025, that puzzle nearly shattered. The delivery of these vital engines froze, caught in the crossfire of renewed U.S.-led sanctions. The entire story paused on a cliffhanger right there on the factory apron. Yet, by mid-year, the restrictions eased. The engines began arriving once more, and the production line, having held its breath, shuddered back to life. That episode was the project's starkest lesson. Strategic independence isn't a slogan. It's an existential imperative. The first serial production aircraft rolled off this line in 2022-2023. The recipient was China Eastern Airlines, the carrier playing the dual role of pioneering pathfinder and, let's be frank, a politically vital partner. Taking delivery of the first C919 is akin to being handed the keys at the most high-profile real estate ceremony. It's a gesture of immense trust and equal burden. They were followed by aircraft for Air China and China Southern. Today, a small but proud fleet, around 28 aircraft, operates in Chinese skies. Every takeoff, every landing is a data point, a shakedown, and a crucial piece of public relations. Passengers are already beginning to forget they're flying on something new and experimental. The plane just works. But COMAC has no intention of stopping here. The Shanghai facility is merely Act 1. Plans for capacity expansion, process optimization, they're all part of the larger playbook. The key word now is scaling. Not a blitz, but a methodical step-by-step fortification of its home turf. The Chinese market, one of the world's largest and fastest growing, must become an unassailable beachhead. Every new jet delivered to a domestic carrier is one less potential order for Airbus and Boeing. Here and now, a quiet, grinding battle for market share is underway. Deliveries beyond China's borders represent the next level, the final boss of this game. For that, merely building the plane isn't enough. An entire ecosystem must be constructed. Worldwide service support, pilot and technician training, a global spare parts logistics network. It's a Herculean task that will take years, yet the vector is set. The C919 is no longer a paper project or an airshow prototype. It is a serial-produced machine carrying passengers, keeping schedules, and proving that the sky above us could have 3 players, not 2, even if for now it's only the sky over China. But a journey of 1,000 miles, as the saying goes, begins with a single hard-fought flight. But behind the facade of triumphant headlines lies a less comfortable truth. The COMAC C919 is, in essence, a brilliant architect who built a skyscraper, but still buys the concrete, glass, and elevators from the neighbors. Its Achilles heel is total dependency on Western technology. The LEAP 1C engines from CFM International, the core avionics, the flight control systems, it's all imported. Beijing is undertaking a Herculean localization effort, developing its own CJ1000A engine, but this is a marathon, not a sprint. For now, the plane is a global kit assembled in China, and any geopolitical tension could turn this kit into a puzzle with missing pieces. The second battle is the fight for minds and wallets beyond the Great Wall, certification. Without approval from the FAA, US, and EASA, European Union, the C919's path to global markets is blocked. This is diplomacy needed with technical regulations. Every clause, every inspection is a negotiation where competitors Airbus and Boeing wield influence comparable to political clout. Even if certification is achieved, the question of trust arises. Is an airline from Indonesia, Argentina, or Serbia ready to stake its business on an aircraft without a 30-year operational history like the A320neo or B737 MAX? Risk is an expensive commodity. And finally, the pressure from the giants. Airbus and Boeing aren't just manufacturers, they are ecosystems with half a century of logistics, pilot training, global service, and political lobbying. They can offer financial packages, trade-ins for old aircraft, and instant support anywhere on the planet. COMAC against them is an agile but lone player. Its main weapon for now is home market support, a market so vast it can serve as a testing ground and financial cushion for years to come. COMAC's answer to these challenges isn't panic, but methodical evolution. While the first series-produced C919s roll onto tarmacs, design bureaus are already drawing up plans for new versions,
the C919-600 and the C919-800. It's the classic play. Stretch the fuselage, cram in more seats, increase the range. Turn a point product into an entire family, just as Airbus did with the A320, creating the A318, A319, and A321. It's an attempt to create its own universe with room for both low-cost and mainline carriers. So the script is unfolding on two parallel tracks for now. Inside China, the C919 is a reality, gaining flesh and blood with every takeoff. It will gnaw away at the share of Airbus and Boeing on domestic routes with the state's silent approval. And on the outside, it remains a shadow on the radar, an object of intense scrutiny, distrust, and respect. Its global fate hinges on one thing: whether in the next 5 to 7 years, it can prove it's not just a political project, but a workhorse that doesn't lose on cost of ownership, reliability, and economics to those who have ruled the skies for the past half-century. The battle has just begun, and the stakes are trillions of dollars and control of the sky of the future.